Hi everyone, welcome to our second day of the confidence intervals unit. Today we're going to be doing the interval for a proportion specifically. Before we get started, I would like for you to complete this warm-up. You can find it on Canvas, download it from there, print it if you want to work it out on that paper or use your own paper. And just spend a few minutes going through number one. This is a review of what we did yesterday. So I will go over the answers after you pause this video and then unpause to check it. All right, so I am going to just remind you guys of a couple things from yesterday when we go over these answers. So the point estimate is one thing to remember it by is that it's the middle of your interval. So remember, it's point estimate plus or minus your margin of error. And so when the interval is in the form A to B, that equals the lower to the upper. And so this is A plus B over 2, and that can be B minus A over 2. There are other ways to find it, but those are the two ways I'm using here. And then sometimes what we're going to learn today is another formula for determining the point estimate and your margin of error in class. And then don't forget about this interpretation that we went over, these two different ones. So confidence interval, you should have the actual interval in your interpretation. And then remember, you use the percent confident right there. And then you need context here, true mean weight of the 1 ounce fun size candy bars. Then for the next one, it says level. So that's just the 90%. Level is going to always start off with in repeated sampling of size whatever. And so the size 25 is key there. And I will put, actually I want to highlight that there. And then I'll highlight where I knew that it said it right there. And then we have the confidence level here. And we want it to be in context. Let me highlight that blue actually. And we want it to be in context. So we say the true mean weight of all one, same exact thing. So that is, and I got that statement from up here where we have mean weight of the candy bars. And so I was just a little bit more specific with that. Okay, so hopefully you understand those, and we can I would recommend that you make some flashcards and start to memorize some of those interpretations, because we'll be using them a lot. All right, now what we're going to do is an activity where we want to try to use a confidence interval to estimate the true value of something. And so if you're in person, we're going to be tossing the globe. I have a blow-up globe that we'll be tossing around. Undecided if we'll be in person on this day yet or not. If we are and you're at school, we'll be tossing this globe around, and wherever your right thumb lands is what I want you to look at. And we want to estimate what proportion of the earth is covered in water. And so we'll be selecting random locations with our right thumb, determining if it's water or not, and then we'll calculate a point estimate for that proportion. So then we'll use that to create an interval of plausible values. If we're at home, I want you to go to random.org/geographic coordinates to choose a random location, and then we'll have a Google form for you to enter this into, and we'll just see what proportion of our class got water as their location and what proportion got some on land. So let's assume that we did this already and we got 25 out of 40 locations were water. So I'm going to just write 25 out of 40 equals 0.625. And I want you to go ahead and use the right notation. That should be our p hat. Remember, that's our proportion from a sample. So we took a sample of 40 locations, either tossing the globe or looking online, and we got 25 of them, or 62.5% of them, covered in water. For the population parameter, sample, and statistic, We'll just do that part together really quickly as well, and then I'll let you pause to finish this part of the activity. So population, we're going to say Earth. And our sample is the 40 locations. These may vary depending on what you had in class. If you weren't in class though, then this is what I want you to be copying down. The parameter, if we had p hat for our statistic, our parameter will be the letter P, and I always put the word true in front of it. True proportion of the Earth covered in water. And then our statistic is what we got from our sample, which is our p hat, and that is 0.625, which we got from doing 25 out of 40. And so now what I want you to do is answer questions 3 through 7. And I need to, so go ahead and answer questions 3 through 7. And then we will pause to debrief, and then you'll finish the rest of the activity. So once you finish question 7, then unpause, and we will go over how to start question 8. If you feel like you know how, you can continue working. Okay, so I just want to make sure you guys have these answers for questions 1 through 7. And then I do want to show you how to do question 8 before we get too far into it. So, sorry. If you need to pause this and check, then just pause and check. We'll debrief after we finish the whole activity. Okay, so before you get too far in question 8, I do want to make sure you understand how to do some of these things first. So in a normal distribution, 95% of the data lies within how many standard deviations of the mean? Remember, this is our 68, 95, 99.7 rule that we're referring to. And so this was 1 standard deviation, 2 standard deviations, and 3. And so that would be 2 there. And that value is called the critical value, but I want to show you how you can use table A or inverse norm, which we haven't learned before, to get these critical values. So we'll start with 80% because that one's going to be a nice, easy one. And so for 80%, what we want to do to simulate it or to visualize this, I want to draw a normal curve right next to it. And then 80% of the data is there. Oh, excuse me. And so this is the middle, and we're looking for z-scores. Remember, this 2 standard deviations from the mean, remember, right here, that describes a z-score, which we remember from our other units. And so the mean is 0 on those. And so what percent is on either side? So what we're looking for is 10% here and 10% there. So that totals to 100%. Now, if I'm using table A, which we'll start with, then remember the percentages under the curve are decimals, 4 digits. And so I'm looking for that lower proportion there, 10% to be 0.1000. So we'll look, zoom in. Here's a 0.09. I'm getting close. I got to go this way. Here's 0.0. Oh, there it is. That's a good one, 0.1003. So if I look at that, that's negative 1.28. So I'm going to write that right here. And then to look at the other one, we're looking for 90% because this value right here has 90% of the area to the left of it. So now I'm going to look for 0.9. Closest thing to it, there's 0.9099, getting there, 9066, and then we have 0.8997. And so that is the opposite of 0.1003, and that should make sense. And we get positive 1.28 because it's symmetric. So we never need to look for both again. What we're going to do is write down 1.28. So I'm going to make a little note here that I want these to be always positive. So what I want you to do now is, well, actually, I want to show you the calculator too. I'm sorry. Let's do that, and then we will move on. You can finish the rest of the activity. So we're going to hit second bars 3, inverse norm. We have not used this before. And so area means the same exact area that we were looking for in the table. I was looking for 0.1000. And you can just type 0.1. Your calculator is smart enough to know that. That's what that is. My mean is 0. My standard deviation is 1 because we're looking for a z-score. Then we hit paste. And so I get negative 1.28. Then again, if I did it again, I could do second bars 3.9000. And I'm looking, hit paste, and I get positive 1.28. And so those are the z-scores that we're going to use for 80% of the data line between the two values. And so I want you to do the same thing for 90, 95, and 99. Inverse norm is much faster than table A, so I recommend that you use it. If you don't know what to enter, I'm going to write a quick little note in red, and you can copy that down. So we're going to do inverse norm, that's second bars 3. And then for area, I'm going to write left tail. Then for mu, we leave it as 0. And for sigma, we write 1. And then always positive, so I'll put absolute value bars around this. And that is what you get. If you have trouble figuring out the left tail, always draw a picture. And we'll talk about a little formula for it after this. So I want you to pause the video, finish this worksheet through the whole rest of the page, and then we will unpause to go over some debriefing. All right, so here are the rest of the answers. And I'll let you just make sure you have those. And then I'm going to go back a couple of pages and debrief some of this. Okay. So a couple of notes to take about what we just did. I want to make some reminders. Remember, another synonym for point estimate is statistic. Right there. So I'm going to just write that right there. And then we have our stuff we already filled in together. Now, what we had to do before we did this activity was check a few conditions. And so the first one that we're going to learn is called the random condition. And so in number 3, we asked you, is it random? And so I'm just going to write random condition. The way you check it, that's condition number 1. So I'm putting number 1 right next to it. The way you check it is you just look for the word random, or you acknowledge that you used chance to get the sample. Our next condition we had to check was, in order to use this standard deviation formula, we had to make sure we had independent, or 10% condition was met. And so that's right here. I'm going to write 10% condition. This comes from our sampling distributions unit, which is our second rule that we need to check before we do it. And this was actually already independent because we sampled with replacement. Someone could have picked the same location as someone else, and we would have used it twice. So that was actually already independent. But if not, we'll check the 10% rule, remember, which is, n is less than 10%, capital N. Could have just boxed that, but. All right, now in number 6, I want you to notice that we actually used an estimate for the P. So in number 4, we're using P, which is the parameter, but in number 6, we don't know P. That's the whole point of doing the confidence interval. And so we used our sample statistic in there, our point estimate. And so this formula, this is called the standard error, not the standard deviation. And it's called standard error because it's an estimate. And so we call it SE of P or S of P hat. And so the formula for it is the square root of P hat times 1 minus P hat over N. And it's almost exactly the same formula. It's just that if we don't know P, we'll be using P hat instead. And then lastly, we had to check the large counts condition. And so that's our third one in order to use normal curves on number 8. So we call it large counts condition, and it is our third check. So in order to do a confidence interval like you did in number 9, 10 on the next page, you have to check these 3 conditions first. And we'll get used to it, but that is all important in order to create a confidence interval. I do have one more thing to write. I want you to round anytime the whole numbers for these. And what ends up happening when we round to whole numbers is we end up just getting our successes and failures. So I'm going to make that note too about this third condition. Let's see if I have room here. There, successes and failures are at least 10. So it's actually not n times p, but n times p hat and n times 1 minus p hat, which ends up being x and n minus x, which is our successes and failures. 25 people had their thumb or found water, 15 didn't find water, and so those are our successes and failures. All right, let's continue. Oops, yeah, here we go to this page. Sorry about all that movement. And so what these are called are critical values. We already wrote some of this down. That's a z-star or z-score. I reminded you up there. And so what we call it is z-star now, since it's a z-score and the star indicates it's like a special z-score specific to that particular confidence level. And so if we have 90%, our z-star will always equal 1.645. 95% is 1.96, which that should be, pretty close to the 2 right here. 2 is an estimate, 1.96 is exact. And then this last one, my stars are ugly, let's fix them, is 2.576. We typically round them to 3 decimals. I'm going to write always positive again, and then usually rounded to 3 decimals if we're using inverse norm. And so we already wrote down that inverse norm note. I'm not going to write it again. Hopefully you have it from previously in the video. All right, number 9, calculate the margin of error. So we're not using b minus a over 2 because we don't have our interval yet. So some of you guys might have tried to do that, but we don't have the interval yet. So this tells us what to do. It says multiplying the critical value you found in number 8 and the standard deviation you found in number 6. And so the critical value is z-star. And the formula we used in number 6 was square root p hat 1 minus p hat over n. So that is our formula for margin of error of a interval for a proportion. The generic form for margin of error is going to equal critical value, which we'll mostly be using z-stars, but we'll learn something else later, times the standard error. Remember, it's called standard error because we're using an estimate for the p. And then to get your confidence interval, we already know this formula. It's point estimate plus or minus margin of error. And so I'm just going to highlight that. Maybe I'll put it in a red box so we keep the colors consistent. And so the point estimate for a proportion is p hat plus or minus. And then we have z-star times square root p hat 1 minus p hat over n. So that's the formula for margin of error, or for an interval for proportion. And then that will get you a comma b as well. So you'll have your lower and your upper, just like that. And then at the end, we're just interpreting the same way we have. I forgot to do the level. I didn't have it on my paper, but I'll go ahead and write that down. So let me just quickly add that. Remember, the level is in repeated sampling, of size. In this case, we did 40. Your class might have done something different. Approximately, and we did a 95% interval. 95% of all intervals calculated or created, same thing, will capture the true proportion of Earth covered in water. And if you know the true proportion, it's somewhere in the 70s. And so I think we did capture it with our interval, so that's great. We were able to get it. And that is it. So I want you to copy down these notes here. This is just all the steps of kind of consolidating everything that we learned. There's one little note at the bottom, and we'll practice that together on the Check Your Understanding. Okay, and I have a couple things I want to add to this. So beginning, this is called, the one I have written at the top, one samples the interval for a population proportion. This is the procedure name. So it's going to be important to us to identify the procedure for each of these problems. So that's the name of the procedure. We have our parameters, the true proportion. We want to identify that. We have our three conditions that we check. We need the critical value to get that. We use inverse norm as the fastest way. So I'm going to write a little note here that this is the left tail that I talked about earlier. So I'll just put a little here, and we have our percent. And then we have that always positive is so important. Confidence interval for P, we have our point estimate plus or minus the margin of error. And so that margin of error, I'll use another highlight tool. Margin of error is all of this. And that's the critical value times the standard error. This is another way to write it. This is how they write it on your formula sheet. And then this last thing, make sure you have it written down, and we're going to practice it on the next page. It's just a formula for solving for the sample size. We'll do some algebra to get it. Okay, so hopefully you were able to do this Check Your Understanding. Sorry if I went too fast. You can pause and try it now and then unpause to check the answers. So here are the answers to number 1. And then I will move on to number 2, where we'll look at this question A. Make sure you guys know how to do it. I'll show you in the calculator. So the formula for margin of error is, critical value. Remember, within 3 percentage points would be a description of your margin of error. So we want that to equal Z star times square root p hat 1 minus p hat over n. Now, if we haven't taken our sample yet, we don't know what p hat is. And so that's when we use 0.5 as an estimate, because that's just 50-50. It's the most conservative guess. We're not leaning one way or the other. So here I know I want my margin error to be 0.03. It needs to be within that, so less than or equal, and then we have our z star times our square root p hat 1 minus p hat over n. We're solving for n. So I'm going to show you in the calculator how to solve for n. Basically, we want to do 3 steps. We're going to divide by 1.96 to get rid of that. Once we've done that, we want to square both sides so that there's no more square root. And then once we've done that, we want to multiply the top, 0.5 times 0.5. And divide it by the answer. So it's 3 steps. Divide, square, and then divide again. And then we always round up. So I'm going to write those 3 steps right here on the paper in red. So we divide, then by C star, then we square, okay, divide by the C star, square, and then divide by the divide answer. Oh yeah, no, divide numerator by answer. Those are the 3 steps. So we'll look at the next one and how to do that in the calculator. We have 0.03 divided by 1.96. Then we square. Then we do our numerator, 0.8 times 0.2. Oh, I didn't write any. Oops. 0.8 times 0.2. And we divide that by the answer, second negative. And that gets us 682.95, and then we round up. So I'm going to write round up for our last step. And we see how we call it conservative because we got a larger sample size required when we use 0.5 than when we use 0.8. So it's more conservative to ask more people. You're being more cautious that way. Check out the answer to C. Make sure you got it. And if you have any questions, please email, and have a great day. Thank you so much.